Hey guys, this is part 2 video for section 2.2. You can see off the left here, we've already done a problem with the elimination method. But the thing with this guy off on the left, and let me use the eraser to show you, that this one kind of had a 5y and a negative 5y, these two variables, ready to cancel. So in other words, you add a negative 5 and a positive 5 and they go away. So if you look at 4, if we try to add down right now, the 2y and the 3y, well, they're not going to cancel one another, and neither is the negative x and plus 2x. So here's the catch with the elimination method, but once you get the hang of it, I think it's still, to me, the easiest way to do it. So true or false, it's legal to do anything you want to an equation as long as you do it to both sides. So in other words, even if you're not sure why I'm about to multiply by 2 on this top one, it would be legal as long as I multiplied everything by 2. So there you go. I multiplied everything by 2. So now let me rewrite this bottom one. And if I was to add them down now, well, the 2x's are going to cancel. So you might have to rearrange the equation a little bit to start with, but it's not that big a deal. Add the y's down, total 7. Negative 2 and positive 30 makes 28. And it's pretty easy from here. Just divide by 7, and I got one of my answers. So just like the substitution method, once you get one of the answers, you have to plug it back in. Now you can plug it into any equation, including the one you changed it to. Again, for no particular reason, although if you look at this bottom equation, the original problem, no negatives, so that's where I'm going to plug it just to make it a little bit easier. So that guy says 3 times y, but we just figured out y was 4, plus 2x, we don't know x yet, equals 30, and then just solve it. So I got a 12 here. Move the 12. Calculator if you need it. Divide by 2. Calculator if you need it. X is 9. Again, just coordinate form is what we're looking for. Now be careful. I did find the 4 first, but I want to go x coordinate first of 9, y coordinate second of 4. And there you go. All right, scroll down here for this last set of problems. It says solve using either method. So obviously, if you knew which one's the best way to go, well, hey, I'm going to go with that one. So on number 5 here, I'm noticing this x all by himself. And to me, it would be pretty simple to get that x all by himself. And if I can get a letter by himself, so I'm moving that 2y to the other side, it makes it easy to do the substitution method. So that's the one I'm going to go with. So I know x equals this stuff. I'm going to plug that stuff right there where the x is. So here we go. Bottom equation said 3 times x, but we just figured out x is the same as negative 2y plus 5. Minus 15 equals negative 6y. So just be careful, make sure you're picking up all the equation that you're plugging it into. Distributed property, negative 6y plus 15 minus 15 equals negative 6y. So this one's going to be kind of unique. Now, if you're going to solve an equation, you got to have the y on one side so you don't get a choice. I would have to move this 6y by adding him. And then keep in mind, there's no such thing as an equation that doesn't have something on both sides. So I can put these two guys together. 15 and negative 15 is 0. And negative 6y and positive 6y is 0. So where'd the y go? It's gone. And if it's gone, that's that special situation where you have either no solution for an answer or infinitely many solutions for an answer. So the question is the statement at the end here true or false? Well, 0 does equal 0, so it's true. And if it's true, the answer is infinitely many solutions. Again, feel free to abbreviate. Okay, so that actually made that one easier because now we don't have to plug anything back in. So for the second problem, what I'm going to look at is substitution method. Can I get a letter by itself easily? Well, at some point, if I chose this top equation, I'd have to divide by 2 to get rid of the 2, and I would create fractions. I might try to think about getting the y by itself, but I'd have to divide by 5, and I would get fractions. And the same thing with the bottom one. No matter what, I'm going to get fractions if I try to get a letter by itself. So I'm going to do the elimination method. But the elimination method requires that something cancels. So if I were to multiply the top by something and the bottom by something different, then I could probably make this work. So in other words, a common number. Well, you can go with either variable, it won't matter. But I'm thinking if I multiplied that top one by 3, I would get a 6x, a 15y, and a 30. Make sure you get that guy on the end. That's a common mistake, is to forget. Well, if I multiplied the bottom one by 2, I would get 6x, but I want them to cancel. And if I want them to cancel, I want to have one negative and one positive. So I could make the top one -3 instead, but since I haven't done the bottom one yet, I'm just going to make him a -2. So -2 times 3 gives me that -6. Those guys are going to cancel. -2 times 4, the 4y would give me -8y. And -2 times 12 would give me -24. Add down. X's cancel. I got a 7y. I got a 6. Divide by 7. I get 6/7. Now, here's what's even more unique about this one. If you took the 6/7 and plugged it back in, that's fine, but you're messing with a fraction. And my question to you would be, does that improve or make your chances worse of getting a correct answer? So you know what? Nowhere does it say you can't start the problem over and find the other letter. So instead of multiplying by these numbers, I'm going to try something different. If I were to multiply that top one by 4 and the bottom one by 5, then I would have some 20y's. I just got to make one of them negative. And again, it doesn't matter which one. I'll just go with the bottom. So 4 times the top one would be 8y. I'm sorry, 8x plus 20y equals 40. -5 times the bottom one would be -15y, -20y, and -60. Sorry, my writing's getting sloppy, but my hand's getting tired. So I've got -7y when I add the y's down. I'm sorry, the x's. These are x's. Whoosh. The y's would cancel. And I've got -20 right here. Hey, 2 negatives, I can make them into positives. And if I divide by 7, that's x. Why am I having so much trouble writing an x? I don't know. It'd be 20 divided by 7. So there you go. There's your 2 answers. So I ended up kind of funky fractions, and it took a little longer to get the answer, but who cares? So I got 27s for x. I got 6/7 for y. All right. Hey, I'm not going to probably have time to finish number 7, but I'm going to start it off. And essentially, again, guys, it's as simple as this. I think most people find the substitution method easier. I like using the elimination method, but I'm still going to say it would be pretty easy to get this little y all by himself. So if I were to, and I'm going to do a little bit of a shortcut here. I'm going to write it, and then you see if you can figure out what I did. So that's me getting y by itself in that top equation. So the question would be, did the 3y move from one side to the other? And it didn't. It stayed on the left side. So the sign didn't change. But what did I do with the 9? I moved him from the right side to the left. Therefore, the sign would change. And I moved the y from the left side to the right. So I moved him, the sign would change. But the point being, you now have a letter by itself, which means we could plug this stuff in right there for y. So I'm going to start this. I had a 7x. I had a -5. That's an x. Why am I doing that? I don't know. So it said 5y, but we changed 5y into 3x minus 9. There was a 25 on the end. Okay, and I'll let you solve that from there. But again, the point being that I am down to just x's. And if I'm down to just x's, it's a normal equation to solve, which I'm pretty confident you guys can handle. All right, thanks for watching Chapter 2, Section 2 videos.